this chapter is entirely about SimDec, how it's built, how it's used, how it can be interpreted. And here we have, as co-authors, a team of contributors to the SimDec open source project, and it's available in many languages. And if you're ever using SimDec and then improving it on the go, it's actually, we're welcoming you to contribute to our community as well. Yes, so in essence, SimDec is a methodology that converts your data, originally simulated data, but could be any other data, to be honest, into an insight of how your model behaves. And here it extracts the most important variables that affect your output or target variable, and then it decomposes the distribution of the output by the combinations of different levels of those most influential variables. And then you can see how they affect the output and how different ranges of the output can be achieved with the combinations of those inputs. Yes, so the algorithm goes like that. We first compute sensitivity indices with simple binning approach. It's a variance-based sensitivity indices, so they show how much variance of the output is explained by every single variable. Then we order the inputs according to their importance, and we select only the most important of them with a certain threshold. Then we divide those selected inputs into the states. So it's usually 2, 3 equally spaced or equally big states with the data points for continuous variables and for categorical or binary or discrete variables, just their numbers. And then we combine all of those states into scenarios. So we have exhaustive combination of all those states, nothing is missed. So practically then the entire data set can be labeled, every single data point can be labeled to one or another scenario. We get all of them in there. And then what we do with that labeling, we produce a visualization, which again on a histogram where every little cube is actually your data point. We color code it with certain color attributed to this certain scenario that it belongs to. And then there is a rule here that the first variable, the most important variable, states need to be colored with contrast, main colors, and then all the other subdivisions go to shades of those main colors. And the beautiful thing here is that the entire process happens automatically. So the picture that we saw just there, it's really like that. You upload the data set, and as a result of SimDec function, you get the visualization with indices. I'll show a bit more about it later. But that's the inner workings of the algorithm. Yes, then in the chapter, we extensively discuss how to interpret the visualizations. And here, if we are talking about degree of influence or how important different variables are, practically the rule is the more the states of the variable are shifted horizontally, the higher is the influence. So if you have, for example, as in the bottom line here, totally different ranges of the output attributed to low and high X, it means that there is a kind of pure strong effect, and it's actually very interesting in terms of the decision making, because by just switching the X from low or high, you get 2 different non-intersecting ranges of the output. Yes, normally the effects look a bit like moderate with a certain overlap, like in the second row. And if there happen to be no influence at all, or very mild influence, then there will be a lot of overlapping of those states or scenarios on the histogram. But then the beauty of SimDec is that it can show the interactions or the multi-variable effects on the output. And here we can see no interaction, like on the first picture, just gradual shift of all the scenarios. Then linear interaction, or practically when x1 is multiplied by x2, you'll see exactly like that. You'll still see a gradual shift, but every time you go to the right or left, it actually increases the range of the output. So the higher is one variable, the more the second variable has the effect on the output. So that's the essence of multiplication here. And think about it, in all business models, like any product price multiplied by volume of produced products, it's like it's so essential. It's like everywhere. So here is where one at a time analysis will already fail miserably, and SimDec already shows that interaction. But then we go to more intricate effects. We actually published a separate paper about it on heterogeneous effects in computational models. And interesting that all those effects like B, C, and D can be with a similar second order effect index, right? They would all, for example, show, I don't know, 10% interaction. But the shape of that effect could be very, very different. And it's where the SimDec visualization is very, very critical. So C, we have the switch of direction of influence. When x1 is low, blue, the increase of x2 gives us higher output values. And when x1 is high, red, the increase of x2 gives us lower output values. This is super important to know when you're dealing with real system, and it's actually a real case we got with the carbon footprint or CO2 emissions life cycle analysis. And the red part was about negative emissions. Julian?
If I could just point out that when you're talking about the switch of the effects, if you look at the two colors, there's a set of kind of red colors and a set of blue colors. When you're seeing the switch, what you see in the red colors is it goes from the lighter color to the darker color. And then for the blue colors, it's going from the dark blue into the light. So one's going light color to dark color, and the other one's going dark color to lighter color. So that's kind of what.
It's like mirror.
Yes, I mean the interpretations of these figures is not necessarily as clean as you will see here. You have to kind of dig into it and get dirty, but this is illustrating what you kind of look for when you are visualizing these things. And as Maria has kind of stressed, when you're doing, call it normal sensitivity analysis with just the values, you don't see this. You know, this is not an effect that you can see without the visualization, or you can't determine without the visualization. So it's a very, very nice component of the SimDec is the actual visualizations of the kind of like the uncertainties as they propagate through the data, which is generally hidden from other forms of analysis.
That's true. And it's a very critical part here, actually, that differentiates SimDec from all the other methods existing there, because that's the part, yes, a bit difficult to interpret, perhaps, but that's the part which allows you to pose open questions about the behavior of your model. What kind of shape of effects, what kind of interactions do my variables produce as an effect on an output, whereas everything else has some kind of close question. So, for example, who is the most important variable, or what's the value of the importance of that variable? So you never get beyond the frames of the paradigm that you are set by or tunneled. Your vision is tunneled by by the methodology that you choose and the closed question that it answers. Here with SimDec, it's like truly explorative approach with truly open questions. And again, in many of the applications in this book, we were genuinely surprised seeing the results. And not just we, the model owners were surprised seeing the results of SimDec. Yes, thank you, Julian. And then last clear type of interaction that we so far have discovered, there could be many more, is a kind of nonlinear interaction, often attributed to some maybe scenarios, a binary variable. And when x1, for example, when x1 is low, blue, you have a very strong effect of x2. And when x1 is high, red, there is no effect of x2, that its states overlap horizontally. And that's another thing which is very important to know. Assume you're a policymaker and you've been told that your x2 is very, very important and you need to put all the resources to bringing it, let's say, high. Well, then no, actually. You only need to bring all the resources to x2, pushing it high, if you manage to secure your x1 being low, then x2 matters a lot. Otherwise, you're wasting your efforts. So these kind of conclusions are enabled by SimDec. And again, it's never, you cannot put values or words into just spaces in between sentences. So it's not like pre-formatted for you. You can discover something that doesn't yet have a template. So that's the power of open questions and power of SimDec to answer them. Then we have a similar visualization for correlations or dependencies, which if you start to model in your models, or if you're dealing with empirical data, you might encounter quite often. So there could be influential variables which have dependencies as well, and practically it shows into certain scenarios being underrepresented or entirely missing on the chart. So yeah, different things there as well. And again, also interesting here, example D, that there could be nonlinear interaction where a certain state is missing only in a certain scenario is missing only in certain state of one variable, but is present in another. It's very common for engineering models due to some physical limitations and restrictions. So again, something to look out if your model has some dependencies, or if you're working with empirical data. And there is way more explanation in the chapter, but also we've made for you a super funny and engaging video available on YouTube. Go ahead and check it out, which actually talks about all those things and also gives you some, as you can see, intuitive examples on how to interpret things. Yes, we had a lot of fun recording it. Yes, so the SimDec tool is open sourced. There is a GitHub organization, a very informal organization for it, and we have there different contributors. It started from SimDec Excel, very primitive Excel spreadsheet with simple macro without global sensitivity analysis yet, but you still can play with the graphics. Then it grew into SimDec MATLAB. Then MATLAB is something that I'm mostly leading and running, and it's something that I've learned once and now cannot unlearn. Keep using it from time to time. And then we have we managed to inspire quite talented people to devote their time to develop packages of SimDec in their languages. So we got SimDec in Julia, we got SimDec in R, and we got SimDec in Python. And you can see that at least MATLAB and Python, and I believe R as well, not that intensively, are very much active. So these are live projects and they're updating all the time as long as we have some new ideas there. And again, there are more ideas than hands or time for their implementation. So especially the Python part has a lot of issues reported for further development. So if you're keen on that, you're very, very, very welcome to help us out with that. It's fun. Yes, but then the true jewel of SimDec is its no-code online dashboard available at simdec.io. And what it works exactly as I showed at the beginning. You just upload your data set here on the panel on the left, and everything else is automatically generated. So the indices, the graphics, the decomposition, everything will be there. And then you have a bunch of things to play with it. So you can try different decomposition or choose different set of variables or choose different visualization type, choose different colors if you wish. So yes, there is a bit of interactivity there. Though if you want to go into really nitty-gritty details, like for example, alter the states, the extent of the states of different variables, then you really need to go into the programming packages of SimDec. Julian, you wanted to add something?
What is the input required for this, or did you say that? I missed it.
It's a data set. So it's a CSV data set, comma delimited format, which has just a bunch of variables, and your variables are arranged in columns, and your rows are the observations. That's it. And one of those variables you need to assign as a target or output variable, or there could be several, of course. So yeah, then you'll be choosing what to analyze and distribution of which variable actually to display here.
I believe Xin-She wants a question.
Yeah, I have a question. Thank you for the wonderful overview. And it's a very good tutorial for me. Basically, I learn a lot. I have two questions, if I may ask. One is, suppose I have a problem. I have no idea how do I simulate or prepare the data. Say, suppose I have 5 parameters. The question is, one is how many data point or sampling point I should prepare. 2 is in what way I should, based on the software, I should prepare the data run. Is that run in any order, or just do you have any in what way we should prepare the data? Good answer.
Okay, so yes, if you have about 5 variables, you can actually make everything is relatively easy. You can assign them uniform distributions with just choosing minimum and maximum values for each. Well, if your model is computationally heavy, well, do at least, I don't know, 500,000 of simulation runs. If you can allow more, do 10,000. The distribution would be much smoother. Here, for example, on the picture, we see a distribution of 5,000 simulation runs, if I remember correctly. If your number of variables increases, then it's better to have more runs. Again, to have a distribution smoother and your effects a bit more precise computed, but it's not an obligation. I mean, if you're stuck with a really, really small data set and there is no way out, we produced meaningful sensitivity indices even for 200 points, under 200 points. So that's the first answer. Did I answer it?
Yeah, it answered. What happens, suppose I have a model, some of the parameter may be either from measurement or whatever the reason, may be more expensive to produce the sample. Other parameter could be less costly. So basically they are not equal. So in that case, should I still use a uniform distribution to generate the data point, or any other distribution I should use?
I'm trying to imagine the situation. Well, I mean, depending on what would make sense. But yeah, I mean, okay, for example, for super heavy model of superconducting magnet design from CERN, we have been using just full factorial design, meaning we've chosen 3-4 points for every single parameter and just checked all the combinations of them, all the meaningful combinations of them. Some of them were just not feasible. So that's it. If that's your situation, you can do that as well.
Thank you, I agree. Because a lot of engineering problem, some of
Yes.
the parameters you wish to measure, they may be very difficult to do, but other parameters may be very easy. That's why it's a similar problem.
Yes.
Thank you.
Yes. Yes, that's true. The only thing you need to keep in mind is that if you're choosing 3-4 points for a single parameter, then of course you're missing everything that goes beyond. And if you're choosing 2 points, you're on a very dangerous situation, because like you're assuming the relationship being linear, and it might not. So at least 3 points per parameter I would recommend, unless you for sure know that it's linear effect.
Thank you.
Yes. Yes, and in terms of the order, I think you asked also, automatically when you load the data to this dashboard, it treats the first variable as an output and all the others as inputs, but you can change it as well. So yes, but
That's good. That's good.
yeah.
Thanks.
Yes, you're welcome. Good to hear that you're almost about to use it already. Okay, what else do we have here? We also, that's done in MATLAB, I think Python and the dashboard so far. So instead of box plots, instead of the histogram, you can also use box plots. Why would you do that? Well, for example, when your data has a very poorly visible distribution in terms of its area, so you cannot see what exactly happening there with shades, or as in here, we can even have some area, but we only can see a single scenario. So distribution is colored in the one single color. And you can actually see in the table on the right, the probability, it has 98% of probability. So 98% of data falls into the first scenario. A certain, was it a risk model? So the probabilities there were important. So we can see that something occurring is quite likely, something else is not. But again, some other scenarios are also present in there. And it's the box plot visualization that allows you to see where exactly they are located on the output distribution. So apart from the dark red bottom scenario, which is visible also on histogram, you see 3 more box plots. And then you also can see that there are a few scenarios clearly missing. So there is some dependency going on in the data, or some correlations in the data or in the model. Yes, and you can see also that you can already interpolate from here that, okay, the lighter the shades, the higher the losses are. Here on the x-axis are the losses, right? So when we increase risk C or risk A, then there are higher losses. But also same holds true, and the jump is quite considerable for the risk B from red to yellow. Yeah, so that's how you can get out from non-readable histogram. Just switch to the box plots. Yes. Oh, actually, I don't have a slide here, but now also in MATLAB and Python and the SimDec dashboard, we have introduced a two-way plot, and it's where you can see You can analyze the two output distributions simultaneously and then see a scatter plot of how those two outputs are interdependent. So they are like some contrasting outputs. Like if you have conflicting goals of optimization, for example, like assuming costs and emissions could be, then something like that is really powerful visualization. Yep. Yeah, so there are not really much conclusions about chapter 2. It's just what you can find there. And it's very practical chapter, very hands-on chapter. And there you'll see the scientific basis for the SimDec procedures and its detailed algorithm, and practically all the references that you might want to have around. You can find them there, as well as in chapter 1 for a broader context. Then there is a detailed discussion on interpretation of the results. Here I showed only the visualization part, but in the chapter you can also find how to interpret the indices. Then there are a description of the tools and their usage instructions, short examples how you can initiate the whole thing and run it. And then there is a discussion on usage nuances. So which variables to select for decomposition, states and scenario formation, how it's done automatically and how you can play with that. And sample size and sampling strategies, exactly the question that we had. There's a bit of discussion in there. But again, the major takeaway here is that SimDec is very flexible. So even if you have a very limited small data set, you can still run it and still get some kind of insight from it. And also discussion on alternative visualization types in the chapter. Hey, Julian, chapter 2 is already outdated. We have super cool 2 output plot.
Volume 2 then.
Or edition second, yes, second edition. Yes. Okay, any questions about that? Okay, no questions. Yes, and all the links. So what there will be link on GitHub. There will be link on dashboard, SimDec dashboard, but it's simple, just simdec.io. And then also link to our Discord community. That will be all in the description of this video. And yes, the SimDec community is exactly where we interact with developers and the practitioners, and help answering questions also beyond this presentation. So welcome.